In this video, we will see how to encode the given bit pattern using Manchester encoding. The rule is extremely simple, by far the easiest one I find it to be. Now 1 represents, as you can see, a reverse Z and 0 represents a Z. So here I see a 1. Now the thing is, the signal will change during the middle of the bit. Yes, you need to keep that in mind. You need to keep one thing in mind, just like we saw in polar RZ, even in Manchester encoding, we will find the signal to change during the middle of the bit. So the signal changes during middle of bit. This is important. Signal changes during middle of bit. Now let's see how this actually happens. Now, when I find a 1, what I do is I represent it using a reverse Z. So reverse Z looks something like this. So this is a reverse Z. 0 is represented using a Z. So I represent it using a Z. 1 represents a reverse Z. So this is a reverse Z. 1 represents a reverse Z. So this is a reverse Z. 0 represents a Z. So this is a Z. 1 represents a reverse Z. So this is a reverse Z. 0 represents a Z. So this is a Z. 0 represents a Z. So this is a Z. Now after encoding the zeros and ones using this rule, you find that the signal is incomplete at certain places. One of them being this. As you can see, there is a discontinuity in the signal pattern at this point. So what I'll do is I'll make it continuous. How do I make it continuous? I make it continuous by joining this line to this. And there is another point where there is discontinuity. At this point, there is discontinuity. So what I do is I simply join it. And now you find the signal to be complete in all respect. So I hope this is clear to you. Thank you.